Hello everyone, welcome to elementary chemistry. We studied last time, we completed till Arrhenius equation, that is till we plotted the law between log k versus 1 by t. So today we'll move forward further. So that is today we'll study about Gardiner equation, that is the demerit of Arrhenius equation, and many more. Hope we complete the chapter in today's video. So Abhi, now we came to know that the unit of K is directly dependent on the unit of A is directly dependent on the unit of K, that is rate constant by unit. So we know like how we calculated the unit of rate constant, that is K, that is concentration to the power 1 minus n and time inverse. So that is the unit of A as well. Now to find the value of R, that is this R, that is gas constant. There are several values of R, so we'll see each one of them. So first one is R is equals to 8 point R is equals to 8.314 joules per Kelvin per mole. R is also equals to, okay, so first we'll see there are three values of R, 8.314, 2 and 0.08314. So for 8.314 there is one more value where R is equals to 8.314, that is for kilopascal Kelvin inverse mole inverse. Do not get confused between this K and this. This is kilo, that is 10 to the power 3 Pascal, and this is Kelvin, that is temperature's unit. Then it is R is equals to 2 calorie Kelvin inverse mole inverse. Then R is equals to 0.0831, that is liter ATM Kelvin inverse and mole inverse. Similarly, R is equals to 0.0831 liter bar Kelvin inverse and mole inverse. So these are some values of R which is very important according to their units. Then we'll see the what is threshold energy. Okay. Threshold energy. This energy is very important actually because threshold energy is actually the minimum energy which is required for the reactant to get changed, or it is the minimum energy which is required to the reactant to carry out any change. It is actually the minimum energy required by reactant to carry out any change. Okay, then we have activation energy. Activation energy. Activation energy is also very important. Activation energy is the energy required to achieve threshold energy. It is nothing but energy required to achieve threshold energy. Okay, so this is threshold energy, this was threshold energy, and this is activation energy. So अब हम समझेंगे कि इसका एक्चुअल मतलब क्या होता है. So let's suppose we have a reactant. ठीक है, this is a reactant at temperature, let's consider 25 degrees Celsius, that is room temperature, just that we consider always. And to change this reactant, okay, to change this reactant into some other, into a product, we required a minimum energy. That is, this is a product, okay. This to this, we require a minimum energy of, okay. Okay, so this is the minimum energy. So we convert from reactant to product. We require certain minimum energy. Okay, that minimum energy is suppose 100 degrees Celsius. Okay, 100 degrees Celsius. So the difference between this is 75 degrees Celsius. So 75 degrees Celsius is the energy which we need to put into the reactant to get converted into the product. So this temperature is 75 degrees Celsius. So this is nothing but activation energy, and this is the threshold energy. Okay. So now let's go to some other examples of activation energy. And okay, so let's suppose these two curves. Okay, let's suppose these two graphs where this is the reactant, and this is the product. This is from reactant to product. This is reactant and this is product. Okay. And here we suppose if this is reactant and the product comes down. Here this is reactant and this is product. This is nothing but energy. This is also energy, and this is the progress of reaction. Okay? Progress of reaction. Similarly here we are. Okay. So in this here reactant is at lower energy whereas product is at higher energy. Whereas here reactant is at higher energy whereas product is at lower energy. So here the product is more stable as compared to reactant, whereas here the reactant is more stable as compared to product. So now we have in actually in this is, we all know this is the activation energy. Okay, and this is also the activation energy. Here this is activation energy. Here this is also activation energy. Okay, so this is also activation energy and this is also activation energy. So this is activation of forward reaction. Yeah, this is activation of backward reaction. So in this, EAF is greater than EA backward, whereas here EA forward is less than EA backward. Therefore, delta E here, the in this one, this case, okay, in this case, delta E will be EA of forward minus EA of backward, that is positive. Whereas here delta E is equal to EA forward minus EA backward will be negative. So delta H here is positive. Delta H here is negative. In this delta E is negative, meaning the energy is released. Whereas here in this delta E is positive, which is meaning energy is given to the reactor. So this is actually endothermic reaction, endothermic reaction, and this is endothermic reaction. Okay, and the whole this is actually delta H, and here delta H is this side, delta H is here. Okay, whereas you also know F whole energy, that is shown energy is average energy minus average energy plus activation energy plus activation energy. Okay, then we move forward. According to according to arrangement's theory, what we observe is according to arrangement theory, where that is the activation energy and the frequency factor, that is A, or free exponential factor A, is independent of temperature according to arrangement theory, but actually they are dependent on temperature. Like, okay, so, therefore, a concept came, that is Gardiner concept, which tell Gardiner concept Gardiner concept, okay, which told us about the dependency of activation energy and A, that is Arrhenius constant, that is the exponential factor and frequency factor, that is dependent on temperature. Okay. So from here we got the values of rate constant, the activation energy, and the value of A. So here K is equal to small a e to the power n e to the power minus E by RT, where this is energy, this is gas constant, this is temperature, where the small a is exponential constant, where T is temperature, to the power n is the power of temperature. Okay, so this is a formula where activation energy EA, that is equal to nRT plus E, where this is a factor, where n is a factor, where the R is gas constant, T is temperature, and E is the energy. Okay, this this actually has a derivation. It's a derivation we have, but we will not be discussing about derivation because this is just a revision video. Okay. Then we'll go to A, formula of A, that is equal to A e to the power n and e to the power n. This n is actually equal to the power of n. Okay. Whatever is the power of n will also be equal to n, this n as well. Okay. Then we move further. That is, if we are given a k overall value. Okay. So let's suppose k overall we have is 4k1, 4k1, k2 to the power 3 by 2, k minus 1 divided by k3 to the power 2. Okay. So how we will find a overall and a overall? From this determine a overall and a overall. Okay. So from this a overall is nothing but the only we do not have to consider the multiple of the constants, whereas rest all we have to consider. Therefore, therefore ई ए ओवरऑल जो है वो है इक्वल टू k1 प्लस 3/2 k2 प्लस k minus 1 k minus 1 माइनस 2 k3। ठीक है। और जो ए ओवरऑल है ए ओवरऑल दैट इज इक्वल टू 4 A1 ए ओवरऑल पूरा सेम होता है एज इट इज द के ओवरऑल। ठीक है। 4 A1 with k2 3/2 k minus 1 divided by k3 square। ठीक है। Then we will go to collision theory। ये से बहुत इजी है, हम लोग बहुत जल्दी कर लेंगे ये। collision theory, let's go। collision theory। ठीक है। जो collision theory है एक्चुअली दिस ऑन। ओके, इसका भी हम 4 पॉइंट पढ़ेंगे। ठीक है। ऑन collision, on reaction occur through collision, all collisions will not lead to product formation। Collision will not lead to product formation। ठीक है। only only those will lead to product formation formation only those will lead to product formation which are effective collision। which are effective collision. Now we will see what is effective collision. What is effective collision? Effective collision is nothing but the collision which occurs by collision with which occurs by minimum minimum orientation, minimum speed, orientation, specific orientation, minimum energy. Okay, collision of the molecules which collide, collision or collide with the molecules which collide with proper orientation, molecules which collide with proper orientation and with minimum energy. Okay, so then this collision theory is most favorable for gaseous state, gaseous state, and fourth one only is only gaseous state is considered. Considered, okay? In this only translation state is considered. Whereas somewhere we see only rotation or vibration state are considered. So, okay, and here only translation state is considered. Now, the rate of reaction for this collision theory means the rate of reaction is equal to total number of collisions multiplied by total number of collisions multiplied by specific collision specific collision multiplied by the minimum number. Okay, so this is rate of reaction. So this is K is equals to root of 8 kBT upon 5 mu. Okay, that is the total number of collision. Total number of collision. Root of 8 kBT 5 mu multiplied by rho multiplied by NA into sigma AB into e to the power minus E naught by RB. Okay, so this is the formula where this stands for the speed, this stands for R rho and NA stands for the orientation, specific orientation, this stands for the area and this stands for the minimum energy. Okay. Whereas for this, if we write for Gardiner concept, according to Gardiner concept, according to Vladimir said, where n is equal to 1 by 2. So k is equal to a e to the power 1 by 2 e to the power minus e naught by rt, where this small a can also be written as root of 8 kb, where kb is Boltzmann function, so kb is equal to 1.38 into 10 to the power minus 23 joule per Kelvin. Okay, 8 kb upon pi mu into rho into Ma into sigma AB into P to the power 1 by 2 into e to the power minus P naught by RT. When this is K, then we have activation energy that is nRT plus E, where N is 1 by 2 RT plus E is energy, so this is P naught. Yeah, this is PA, this is K, this is activation energy, and we have capital A, that is Arrhenius constant or frequency factor or the exponential factor, where A is equal to A e to the power n and e to the power n. So we have A of half. So this is A. The here mu is reduced mass, where m1 plus m2, that is m1 into m2 by m1 plus m2. This is where m1 is mass of first molecule in the first molecule of reactant, whereas where m2 is the second one. Okay, and here sigma AB is nothing but pi DAB square, where DAB is equal to mu plus dE by 2. Okay, okay. So now we'll see transition state theory. That was collision state theory. Now this is transition state theory. So transition state theory. In this theory, we know a transition state is nothing but the intermediate between the reactant and the product, which is formed. That is not a permanent state. It is a temporary state. The energy of the state is very high. Okay, so we will see few points for this. The transition state theory. Okay, first one, transition state theory. Reactant is converted to product via transition state. Okay, reactant is converted. I request everyone, if whoever is watching this video till now, please write with me so that your notes are also formed simultaneously. Okay, so this is reactant is converted to product via transition state. Okay, Then transition state or X, we can consider this as transition state. Then second point, the reactant and the transition state and the transition state are always in equilibrium. Okay, so it is like A plus B giving an equilibrium, giving a transition state to product. Okay, then third point, the rate of this reaction. Rate depends on rate depends on two factors. That is how much concentration of transition state is formed and the frequency of decomposition of the transition state. The first one is how much concentration of transition state is formed and जो दूसरा है the frequency of decomposition of transition state position of transition state इसका मतलब हुआ कि कितना concentration of transition state बन रहा है और कितना जल्दी वो घट रहा है ट्रांजिशन स्टेट घट रहा है मतलब प्रोडक्ट फॉर्म हो रहा है और कितना जल्दी वो A+B से बन रहा है ठीक है और उसका जो फोर्थ वाला पॉइंट है ऑफ ट्रांजिशन स्टेट इज कि दिस कंसिडर्स ट्रांसलेशन मोशन रोटेशनल मोशन एंड वाइब्रेशन मोशन सब कुछ कंसिडर करता है इसका मतलब कंसीडर्स का मतलब कि जो ट्रांजिशन स्टेट है विल शो ट्रांसलेशन मोशन एज वेल जो ट्रांजिशन स्टेट है ट्रांसलेशन मोशन भी दिखाएगा प्लस रोटेशनल मोशन भी दिखाएगा प्लस इट विल शो ट्रांसलेशन मोशन भी दिखाएगा रोटेशनल मोशन भी दिखाएगा प्लस इट विल शो वाइब्रेशन मोशन मतलब एक पोजीशन पे वाइब्रेट होना प्लस ट्रांसलेशनल ट्रांसलेशनल रोटेशनल एंड वाइब्रेशनल मोशन ओके सो ये थे इसके चार पॉइंट्स अब हम देखेंगे कि इसका फॉर्मूला क्या होता है ना एक्चुअली हाउ वी डिराइव द रेट ऑफ रिएक्शन ओके सो सो रेट ऑफ रिएक्शन रेट ऑफ रिएक्शन जो है दैट इज इक्वल्स टू concentration that is equals to concentration of transition state फॉर्म फॉर्म मतलब कितना मल्टीप्लाई बाय फ्रीक्वेंसी ऑफ ट्रांजिशन स्टेट डीकम्पोज ओके सो कॉन्सेंट्रेशन ऑफ ट्रांजिशन स्टेट जो फॉर्म होता है दैट इज दिस इज रेट ऑफ रिएक्शन तो कॉन्सेंट्रेशन ऑफ ट्रांजिशन स्टेट फॉर्म हम कैसे लिख सकते हैं ठीक है, तो ये है, दिस इज इन इक्विलिब्रियम, दिस इज इन इक्विलिब्रियम, देयरफॉर के इक्विलिब्रियम इज इक्वल टू प्रोडक्ट डिवाइड बाय ए into B. So concentration of this form is equals to this is equals to K equilibrium A into B. ठीक है, whereas the frequency of transition state है that we can find as, ठीक है, this is equation 1.2. Then we know energy of intensity जो है is equals to total energy. ठीक है, जो टोटल एनर्जी है दैट इज इक्वल टू के बी टी, वेर एनर्जी ऑफ इंटेंसिटी इज इक्वल टू एच म्यू इज इक्वल टू के बी टी। ठीक है, तो म्यू जो है दैट इज इक्वल टू के बी टी बाय एच, दिस इज म्यू। सो देयरफॉर rate of reaction therefore rate of reaction is equal to k equilibrium a b into kBT by H। ओके, इसमें kBT by H हो गया, therefore जो kB है that we can write by R by NA। ठीक है, that will, वो बाद में करेंगे, हम पहले इसको और सिंप्लीफाई करेंगे। ठीक है, that is rate of reaction is equal to K equilibrium into kBT by H को A into B, we can write this as K, that is K concentration of A into concentration of B, where K is equals to K equilibrium KBT by H, that is equals to K। ठीक है, सो हमें पता है कि we know from thermodynamics कि delta G equals to minus RT ln K equilibrium है। We also know delta G is equals to delta H minus P delta H. We also know delta H is equals to delta E plus delta mgRT। ओके, सो इसमें से हमें क्या पता चलेगा, अगर एल एन के इक्विलिब्रियम लिया हमने इज इक्वल्स टू डेल्टा जी माइनस आर टी। ठीक है, एल एन के इक्विलिब्रियम, सो फ्रॉम हियर ln के इक्विलिब्रियम इज इक्वल्स टू माइनस डेल्टा जी बाय आर टी। वी नो डेल्टा जी इज इक्वल टू डेल्टा एच माइनस टी डेल्टा एच, तो हम लोग यहीं पे लिख लेते हैं। दिस डेरिवेशन इज एक्चुअली वेरी इंपॉर्टेंट, क्योंकि इससे डायरेक्ट क्वेश्चंस भी आते हैं कभी कभी, कि वो तुम्हें पूछ लेंगे कि व्हाट इज एल एन के इक्विलिब्रियम, व्हाट इज दिस, व्हाट इज दैट, तो हमें वो सब कुछ पता होना चाहिए। सो माइनस डेल्टा एच प्लस टी डेल्टा एस, ये आर टी, ये भी आर टी, ये टी टी हो गया कैंसिल। सो हमने इनको मिटा दिया, टी टी हो गया कैंसिल। सो एंड वी नो कि डेल्टा एच जो है दैट इज इक्वल्स टू डेल्टा एच जो है डेल्टा ई मतलब माइनस डेल्टा ई माइनस डेल्टा mgrt divided by rt divided by rt plus delta s by r. तो इधर से RT कैंसिल हो गया. Therefore, therefore K equilibrium is equals to e to the power minus delta E by RT into e to the power minus delta NG into e to the power delta S by R. Okay, so that is this is equal to K equilibrium. So अगर हमने K equilibrium को यहाँ पे substitute किया where this is rate constant K equilibrium, so that implies K is equals to KBTH KBT by H e to the power minus delta mg into e to the power delta s by r into e to the power minus delta e by rt. Okay, so from here this we can write as rt by nah into e to the power delta Lg into e to the power delta s by r into e to the power minus delta e by rt. So this is the formula of rate constant for this is the formula for rate constant for transition state theory. Okay, so we can also, if this is the relation of K and delta S, we also can write delta S is equal to A plus RT into delta Ng minus 1, where delta Ng is equal to Ng is equal to solution of product minus solution of reactant. So if in this reaction A plus B, that is transition state X gives product, so this is summation of transition state is 1 minus summation of reactant is 2, that is equal to minus 1. So this is also a very important formula. Okay, so now we move further where, okay, if we are given to calculate Gardiner concept for this, we have to relate Gardiner concept with this transition state quickly. So we can also write according to that, where there k is equal to a t to the power m e to the power n e to the power minus e by rt. So here a t to the power 1 e to the power minus delta e by rt according to Gardiner concept, where and we know activation energy EA is equal to E, we know activation energy equals to E plus nRT, so RT, where A is equal to A t to the power n and e to the power n, so that is equal to A t e to the power 1. So here from here we know A is equals to, where A is equals to R by NaH e to the power minus delta Nb into e to the power delta S by R. Okay, so if we substitute this into this and we write ln of A is equal to ln of R by NaH minus delta Nb, so this is for transition state, plus delta S by R ln plus ln of t plus 1. So this is also a very important formula. Okay, then you move further on the effect of catalyst on rate of reaction. Okay, effect of catalyst on rate of reaction. Okay, if we have a normal reaction A to B, and we have a reaction where A to B is according to catalyst. So in this, we plot a graph for activation energy, and this is the reaction A, and this is for B. Then if this is the activation energy or the reaction path, reaction progress. So this is for normal without catalyst. This is for equation 1, this is equation 2, this is for 1, this is for 2, this is with catalyst, this is without catalyst. So activation energy of uncatalyzed uncat will be greater than activation energy of catalyzed. Okay, then we move further to enzyme. Similarly, with this category, we go to enzyme catalysis. Enzyme catalysis is very important topic. Enzyme catalysis, this has actually has a derivation, but this is a division series, so we are not doing any derivations. We are doing only derivation for certain things which is very important for the division. Okay, and then substrate in equilibrium will give enzyme substrate that is K1 is K-, where enzyme substrate will give enzyme the product that is K2. Okay, this is the reaction. For this, in this rate of reaction is equals to K2 P naught S by S plus Km, where Km is mechanism maintained constant. Uh, mechanism maintained constant, where this is equals to K1 plus K2 by K1. Okay, that is equals to Km, where rate of reaction is equals to this. So this is also a very important thing. Okay. So next we have to use the graph for enzyme catalysis or mechanism plot. So in graph placement graph in case of this if concentration of X is greater than KL, concentration of X is greater than KL, then the rate of reaction is equal to K2 E naught because this is 0, approximately equal to 0, and this is as and I should cancel to K2 E naught, where this is also R max. Okay, where if this is the first case, then second case is concentration of S is less than Km. Concentration of S is less than Km. Then the rate of reaction is equal to K2 E naught S by Km. And Km. Then the third case where where concentration of S is equal to Kl. The rate of reaction is equal to K2 E naught by 2 because if this is equal then this is a concentration S, so 2S, so SS for cancel, so 2. So this is 2, so this will be R max by 2. So if we plot a graph, then if there is so if we plot a graph, if we plot a graph of rate versus concentration of S, rate versus concentration of S and this. So if in this case the concentration of S is 0, that will be uh, it will be constant. Rate of x versus rate. So slope is K2 E naught Km y equals to Mx where it is 0. So this will be a plot of this. Then from here when rate is when rate of reaction reaches a maximum point, so it will be independent of concentration of air, so it is R max. So it will be in a straight path. Okay, so this is R max, and the half of this will be R max by 2. R max by 2. Okay, and here in this concentration of air is equal to KL. Okay, this was the graph for metallic standard constant. Now in this urban analysis we have another plot for line lever group plot. Line lever group plot. In this, touching of the reverse of technique measure plot, this is that was rate versus concentration of S. This is 1 by rate versus concentration, 1 by concentration of S. So there it was rate is equal to, there it was rate of reaction was equal to K2 E naught X by X plus A, whereas here the rate is reversed. So 1 by rate is equals to concentration of S plus N divided by E naught S. So in this, we see 1 by 8 is equal to 1 by K2 E naught plus Kn by K2 E naught S. So here Y is equal to Mx plus C, where the slope is Kn by K2 E naught and C is 1 by K2 E naught. Okay, so if we plot 1 by weight divided by 1 by concentration S, so it will be a straight line with M is equal to Kn by K2 E naught. Oops, we did a mistake by doing this because we have an intercept and the intercept is not 0. Therefore, we start from here. So M is equal to Kn by K2 E naught and C is equal to 1 by K2 E naught. Okay. Then we'll see turnover number and turnover frequency. What is turnover number? It is the ratio of it is nothing but K2 turnover number is equal to K2. What is turnover number? It is the total number of reactant. It is the total number of catalysts used to form reactant divided by total number of. Okay, so turnover number is number of moles of reactant reacted, number of moles of reactant reacted divided by total number of moles of enzyme used. Whereas, or we can also consider it as number of moles of product formed divided by total number of catalysts used. So now we can write it as turnover number. So we will write turnover number total number of moles of the number of moles of reacted 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 or product formed divided by divided by number of actually number of moles of reactant reacted divided by total number of moles of enzyme or catalyst used. And then we then we find parameter frequency that is equal to time over number divided by time that is equal to T. Okay, then catalytic efficiency efficiency that is theta that is equal to T by 11. Okay. So now we'll go to signal mechanism of unimolecular reaction. This is also a very important subject. Unimolecular reaction of unimolecular reaction. Okay. In this, we have a unimolecular reaction which is getting reacted with itself. So A plus A will give equilibrium, equilibrium actually. Will give A star that is a transition state plus A, and this is K1, this is K minus 1. So then this transition state A star will be a product. Okay. So rate of reaction that is equal to K1 K2 A square divided by K minus 1 A plus K2. So this is the rate of reaction for this reaction. So low concentration of A, so low concentration of A, we have rate of reaction is equal to low concentration of A, so this is going to be 0. So K2, so K1 A square at high concentration of A, we have the rate of reaction is equals to K1 K2 A by K minus 1. Okay, so if if there's another reaction of A to B where rate constitutes K dash, so K dash A is the rate of reaction for this reaction. So rate of reaction equating with this reaction is K dash A will be K1 K2 A square by K minus 1 A plus K2 A. This A and A got cancelled. Therefore, K dash is equal to K1 K2 A divided by K minus 1 A plus K2, where this is effective phase constant. Okay, this one. So if we plot a graph for this at okay, so at low concentration of A, if you see here, then K dash is equal to K1 A at high concentration of A. At high concentration of A, we have K1 K2 divided by K minus 1. So K1 K2 divided by K minus 1. So if we plot a graph, if we plot a graph of K dash versus concentration of A, So at low concentration of A, we have a, order of 1. So it is a first order reaction. Then at higher concentration, when we move higher concentration to A, then it is independent of A. Therefore, it is constant. Okay. There's another formula for Q dash, where Q dash is equals to 1 by A1 minus 1 by A2 divided by 1 by K1 minus 1 by K2. This is also a formula to determine effective rate constant. Okay, so we'll move further to kinetics of ionic reaction. This is the last topic for chemical kinetics. Kinetics for ionic reaction. Okay, so in this kinetic ionic reaction, A plus B will create equilibrium to transition state will be a product. Okay, so here we know K equilibrium is equals to transition state divided by concentration of A into concentration of B, that is product by reactant. But actually for ionic reaction, the concentration is written in the form of activity, where activity is equals to gamma into concentration of the substance. So gamma is activity coefficient. So therefore K equilibrium is equals to gamma x the concentration of X divided by gamma A into concentration of A into gamma B into concentration of B. Okay, so this is represented as activity of this the activity of A into activity of B. So this is the way it is written for ionic reaction. Therefore, from here, to find the rate of reaction, we require the concentration of gamma, that is concentration of transition state formed, multiplied by the frequency of decomposition of transition state. Okay, so from here we'll find the concentration of transition state, that is equals to K equilibrium gamma A into gamma B into concentration of A into concentration of B divided by gamma of transition state. Okay, so this is concentration of transition state. Now the rate of reaction can be written as concentration of X into transition the frequency of decomposition. So K equilibrium into gamma A into gamma B into concentration of A, concentration of B into concentration of mu divided by gamma of X star. So Therefore, rate constant, that is K, is equals to K equilibrium gamma A into gamma B divided by gamma of X star, or into frequency as well. Okay, so this is for kinetics of ionic reaction. Then kinetics of non-ionic reaction. Kinetics of non-ionic kinetics of non-ionic reaction. It is also in a similar manner where K equilibrium is equal to transition state divided by concentration of A into concentration of B. But here we will not be using activity because this is non-ionic reaction. So the concentration is written as the same. So in this, rate of reaction is equals to K equilibrium concentration of A, concentration of B mu into mu. Therefore, therefore K is equals to K equilibrium into mu. Where if we divide 1 by 2, so K by K naught, that is non-ionic. So it is like gamma A into gamma B divided by gamma X star. So this is for non-ionic reaction. Now we'll go for relation of activity coefficient, that is gamma, and ionic strength, that is I. This is relation between uh, activity coefficient and ionic strength. Okay, so in this, log of gamma A gamma B is equals to minus A mod of ZB mod of root I, where ZA and ZB are the ionic charge for molecule A and molecule B. Then here this is therefore log of gamma A, log of gamma A is equal to minus A mod of ZA mod of root I, log of gamma B is equal to minus A mod of ZB root I, to log of gamma for transition state is equal to minus A mod of ZA plus ZB into ZA plus ZB root I, and therefore log of K by K naught is equals to log of gamma A plus log of gamma B minus log of gamma of transition state, that is from here. If we see k log of k by k naught is equal to gamma A gamma B by gamma of transition state. So that implies log of k by k naught is equal to 2a mod of ZB mod root I. Okay. Now it is an optional topic. If you want to study, then you can. But it is a very higher order higher order question comes usually from this topic, that is the relaxation time or the relaxation method. Relaxation method. Okay. Here tau represents relaxation time. रिलैक्सेशन टाइम ओके सो अगर हमारे पास एक रिएक्शन होगा विच इज इन इक्विलिब्रियम ऑफ ए एंड बी दिस इज k1 दिस इज k minus 1 so tau is equal to 1 by k1 plus k minus 1 ओके सो सिमिलरली हमको अभी सब रिएक्शंस का लिखना है जैसे कि अगर हमारे पास रिएक्शन है कि दैट इज 2a is in equilibrium with b that is k1 and k minus 1 then tau is equal to 1 by 4 केवल इसका कोई लॉजिक नहीं है कि कुछ वैसा नहीं है बट ये सिर्फ एक फॉर्मूला है जस्ट टू फाइंड द रिलैक्सेशन टाइम फॉर दिस रिएक्शन सो इस रिएक्शन के लिए रिलैक्सेशन टाइम ये होगा इस रिएक्शन के लिए रिलैक्सेशन टाइम ये सो इसके लिए रिलैक्सेशन टाइम इज ए नॉट प्लस के माइनस वन सो हम कैसे याद कर सकते हैं इसके लिए वन बाय के वन माइनस प्लस के माइनस वन इसके लिए वन बाय फोर क्योंकि ये रिएक्टेंट के साइड में है तो फोर अगर इसके साइड में है तो हाफ ओके सो इसके साइड में है तो फोर के वन दिस इंटू ए नॉट प्लस के माइनस वन ठीक है वैसे ही सिमिलरली अगर ए प्लस बी हुआ will give C. So K1, K minus 1. So tau is equals to 1 divided by K1. A, this is in equilibrium. Concentration of K1 AE plus B plus K minus 1. Then it is A to B. That is K1 K minus 1. So tau is equals to 1 by half K1 plus 2k minus 1 BE. Okay, then the last one is A plus B K1 K minus 1 C plus D. So इसका tau is 1 by K1 AE plus concentration of BE plus K2 concentration of CE plus concentration of DE ठीक है सो इसका वैसे ही हाफ ऑफ के वन प्लस प्लस टू इंटू के माइनस वन इंटू बी फिर इसका है के वन इंटू ए ई प्लस बी प्लस के माइनस वन। तो इसका है 1/4 K1 AE plus K minus 1. ठीक है, so this was the relaxation time का for this reaction, और ये उसका relaxation time, ये उसका, फिर ये relaxation time, फिर ये इसका, और ये इसका relaxation time. अभी हम देखेंगे कि एक लास्ट है, that is fast reaction or diffusion control reaction. Fast reaction, diffusion control reaction, जो इसमें है, इसमें एक ही फॉर्मूला है, और फिर डिफ्यूजन कंट्रोल रिएक्शन के लिए केडी, दैट इज कांस्टेंट, रेट कांस्टेंट फॉर डिफ्यूजन कंट्रोल रिएक्शन, and that is only for fast reaction, that is 8/3 RT by eta, RT by eta, जो eta है, that is viscosity. Okay, so this is viscosity. Newton second square, meter square, that is equal to joule second per meter cube, where 1 Newton meter is equal to 1 joule. So this was the last topic for the chemical kinetics. Next chapter, I think we'll do an organic chapter, that is a basic chapter of organic chemistry. That is maybe GOC, that is general organic chemistry. So this is the last hope. You all like the video. Please like, share, and subscribe. If you have any doubt, please comment down below in the comment section. So I will revert back to it. Hope you like the video. Thank you so much. Keep learning and stay safe. Thank you.